All right, so ln both sides of this and simplify. So again, not doing any calc yet. I want you to do what we did the very first day of this lesson, which is to take a natural log that is a singular natural log and break it into multiple. So you should have 3 natural logs on the right side of the equal sign.
Keely Acorn and Ricky Schmaltz, please come to the office. Keely Acorn and Ricky Schmaltz, please come to the office.
So again, everywhere you have multiplication inside a natural log, we can turn it to addition of 2 natural logs. Where you have division, it becomes subtraction. All exponential powers can be brought down in front as coefficients. So this becomes the natural log of y equals 3/4 the natural log of x plus 1/2 the natural log of x squared plus 1 minus 5 the natural log of 3x plus 2. Are we good with this idea? Does that... What? Take your derivative. So what's the derivative of the natural log of y? It's like the derivative of the natural log of x. What's the derivative of the natural log of x? 1 over x. So, but since it's a y, it just becomes exactly 1 over y. So it becomes 1 over y times, anytime we take a derivative of y, what do we have to tack on behind it?
Oh, dy.
So it's 1 over y, dy dx. Just like it's 1 over u, du dx. What is the derivative of 3/4 the natural log of x? So 3/4 or 3 over 4x, because it'd be 3/4 times 1 over x. And at this point in time, you can stop writing dx dx. So like, it would be, because again, we are doing implicit, it would be like dy dx, 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 dx. We know dx dx is 1, you no longer need to write. Okay, what would be the derivative over here?
Or no, we do 2 times 1 so 2x squared.
Yep. So it'd be 1/2 for the coefficient times derivative of 1 over u, which is 1 over x squared, times the derivative of x squared plus 1, which is 2x, which was number 42, or 40 rather, in your homework last night, was deriving the natural log of x squared plus 1. So now we're just extending it and putting it in the middle of the problem. Okay, and then minus 5, natural log of 3x plus 2 becomes 1 over 3x plus 2 times derivative of 3x plus 2, which is 3. When we started learning implicit, what did we solve for? So what do I have to get rid of over here? So we're going to multiply both sides by y. What happens to the 2x and the 1/2? So that leaves you with x over x squared plus 1 minus 5 times 3, which is 15, 3x plus 2. You're not going to simplify. All you're going to do is plug this in for that y. So it's going to be x to the 3/4 square root x squared plus 1 all over 3x plus 2 to the 5th. And then that's times the quantity 3 over 4x plus x over x squared plus 1 minus 15 over 3x plus 2. And you are done. Do not simplify these x's. do not simplify those x's. You cannot simplify those x's right there. Yes.
You want to put money on it?
I mean, you can, but you'll get it wrong.
So we don't have to like multiply that?
Nope.
There's so much.
So like you're done.
This table is covered in this stuff.
Ew.
Everything is dead.
That's quite sad.
Wait.
Yeah.
I opened the can is a tiny thing, and it's the densest thing.
So, the purpose of this lesson is to make hard things simpler. If you look at the next example, what do you think our thought process is going to be to simplify a x to a square root of x?
It's really easy to do it normally.
Oh,
Do you know how to take the derivative of a variable to a variable?
No.
It is not a power rule, so you have to ln both sides. So, like, you cannot take the derivative of a variable to a variable. This is not like x squared. This is a variable to a variable. I want to reiterate that. A variable to a variable. We've done it so far where it's a variable to a power or a function. We've done it where it is a constant to a function. You cannot do a variable to a variable without ln'ing. So, ln both sides.
So you can have a variable or a power to the power of a power. Is that possible?
A power to a power to a power.
Yeah, like when we get like 10 to the x squared.
You could do that.
Yeah, 10 squared.
Not that, but yes.
You can do that.
Okay, so
You can do
this becomes a coefficient in front of the ln because it is the power of the function of ln. We can bring it out as the coefficient. So you have ln y equals square root x ln x. Now take your derivative. So to imply that I am now taking the derivative, you kind of write that d dx out front. So it's the derivative of this with respect to x. So the derivative of the natural log of y is always this involves what type of rule? So it's the first times derivative of the second plus the second times derivative of the first square root x divided by x could be simplified to or yeah, square root x over x. But why would I want to write it like this? And then what's in my denominator over here? So what's this side need so I can add these together? So these are like terms. So you get 2 plus ln x over 2 square roots of x.
So where's the 2 go from?
I multiplied by 2 over 2 to create a common denominator. What do I have to get rid of that is still happening over here? Yeah, I don't want that 1 over y as part of this. So I'm going to multiply both sides by y. But y is really x to the square root of x. And you are done. So one of the big things I saw on our quizzes 2 quizzes ago was combining these like terms. We tried to just automatically make this 2 square roots of x the denominator of all of this. Or you tried to like take 3 things being added where you had a denominator and just made it a common denominator. Remember, you have to manipulate things being added together to have the same common denominator. You can't just automatically turn this into one thing. Or you would have lost that 2 there. It would have been a 1, which is a different answer. Yeah.
It's on the brain part. So the square root of x over x is 1 over the square root of x.
The square root of x over x is 1. Yes. Because this is like x to the 1/2 power. This is like x to the 1. So if you have x to the 1/2 over x to the 1, you subtract them. So 1/2 minus 1 is negative 1/2. So it drops to the denominator as positive 1/2.
So you would have just left it like y instead of x to the square root of x.
Gotta plug the y back in. Gotta plug back in the original. Okay, what we haven't looked at yet is the combination of ln's and trig. So, what we're going to do is look at deriving natural logs with trig. What could we do to make this problem simpler? Yeah. So don't get into the habit when we do a lesson, you think, oh, I just ln both sides to start. I have to ln both sides for this problem. I love that like you recognize I don't need to ln both sides. I already have the natural log of a variable to a function and can bring that function down.
Oh, don't worry, I always ln during my teacher because I was like, oh wait.
I mean, you could have eat it. That would have been a little better than ln'ing it, because at least it would have canceled the ln. Okay, so we get y equals cosine x times ln x. This is now just a very simple product rule. Okay, well, I lied. Because look at where your parenthesis is.
Oh, it's not the variable.
It is not to the variable. So when I looked very quickly, I interpreted the parenthesis as being there, but where is the parenthesis? It is not. It is here. So you do have to ln both sides. Or e it, but I would ln it. I did. But I used to, in my examples, have it where the parenthesis was here and then there.
Wait, so ln,
And I deleted it.
ln x.
Yes.
What?
Well, at least I chose not to have a pen.
So
I
now,
never said I
So
chose.
now you can bring it down.
Wait, now you can have the x inside the.
Because I LN'd it.
Okay.
So, like, oh, I added extra parentheses. Like, that X, like, see how I have double?
Yeah, can you do that?
Yeah.
Does that make a difference?
It doesn't matter. Like, see how I have it here and go up there?
Yeah.
Same thing.
You have to take the derivative twice. 1 over x and, well,
That's gonna be 1 over ln of x.
Yeah, if I derive this now, so take your derivative, right? 1 over y, dy dx. Derivative of, well, first, we'll do the first times derivative of second. This is like a natural log of u. So it's 1 over u
over ln x.
times derivative of u. Derivative of ln x is, derivative of x is, just a good habit to form, plus the second times derivative of the first. Derivative of cosine is, so then dy dx becomes y times the quantity x ln x whole minus sine x ln x
What's the cosine do?
I forgot to write it. Yeah, thank you.
That's a
Wait,
lot,
cosine
right?
of what?
X, ln x.
Do you then plug in ln x cosine?
Yeah. And then you'll just plug that in your original.
This one I'm gonna have to circle my answers. There's so much.
It's just hard.
Okay, go ahead, Rich.
Okay?
Okay. Go for it. What do you?
Example 4. We have y equals 5 to the negative 1 over x. Type of problem is this?
Cool. I don't like brackets.
The exponential.
Yeah, this is an a to the u. Because it's like a function, not just x. So, rule for a to the u is rewrite the function. Times it by the derivative of the exponent. So derivative of negative 1 over x is, yep, x to the negative second, or 1 over x squared. And what do you have to add or tag along?
Oh, 1 over.
Just down line.
Um,
The 1 over is for logs. You can't really make that pretty, right? Like, your numerator will be the natural log of 5. Your denominator will be x squared and then 5 to the 1 over x. Because it's a negative exponent, so you could drop it to the denominator as a positive. It really isn't. Bless you.
Whoa.
Thank you. Oh, you saw me sitting like this.
I was gonna say, it was written all over his face. I could just see he was gonna sneeze.
What are you doing?
Whoa.
What are you doing?
Exactly.
I'm not. What are you doing?
Over there.
What are you doing?
What do you look at the answer like?
Oh, I'm sorry.
He's
I was
actually
looking
not.
at
He's
it.
actually
Yeah,
not
you
about
couldn't
to
see him.
Yeah, so I didn't know he was like.
All right. Derivative of y equals x to the 1/2 natural log x. Just a product rule, right?
Get her done.
Okay, would you rather a bookwork or a worksheet?
No.
Yeah.
I don't care.
I did both.
I want this to work because I'll do the worksheet for review later on.
Okay. So back in our books we go to 179. done 1 through 10. We've done 12 to 30 minutes. Then we went like, yeah. So what I want to do is pick up at 31 and do the odds through 47. Yeah, because we did some of these, so I have to change this a little. Yeah, that's what I said. I think I switched my days around a little bit, based on stuff I don't know what happened. And then I just want to do a couple of the multiple choice reviews, so the true, false, etc. So you're going to do the 57 to 68.
Aw.
I mean 62, sorry. The problem started with an 8. 57 to 62.
I was gonna say.
That's a lot of multiple choice. They don't usually have that.
I know, but
It's always 5 problems there.
it's all for that one, right?
Yeah.
Alright.
So 6 there and those there. And that's just the odds.